In the last lecture, we had started discussion about empirical formula and molecular formula. So now we will study about the detailed derivation by which we can calculate both of them through some percentage and the molecular mass of any given compound. So let's start. So the first problem, we will understand this through a numerical problem, okay. So the question is, a compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molar mass is 98.96 grams. What are its empirical and molecular formulas? Okay. So, there are many steps to solve this question. Step 1 is convert percentage to mass. Okay. So, see, all the elements are given in percentage. If we consider that the total amount of the compound is 100 grams, then we can easily consider these percentages in mass, that is in terms of grams. Okay. So, for converting percentage to mass, let's assume total mass of the compound is equal to 100 grams. Okay. So, mass of hydrogen in the given compound is equal to 4.07 gram, right? Mass of carbon in the given compound is equal to 24.27 grams. Mass of chlorine, okay, mass of chlorine in the given compound is 71.65 grams. Okay, so we have converted percentage to mass. This was the step 1. Now, step 2. In the step 2, we have to convert mass to number of moles. We have already learned the formula of conversion of mass to number of moles. So, what was this? Number of moles is equal to given mass by molar mass. Okay. So, first we will find out number of moles of hydrogen. So, number of moles of hydrogen. So, the given mass of hydrogen is 4.07 grams. Okay. So, 4.07 grams divided by molar mass of hydrogen is 1 gram. So, this is equal to 4.07 moles. Okay. Now, number of moles of carbon. So, what is the number of moles of carbon? So, this is given mass of carbon is 24.27 grams. So, 24.27 grams divided by 12 grams, that is the molar mass of carbon. This comes as 2.02 moles. Now, number of moles of chlorine. So, given mass of chlorine is 71.65 grams. So, 71.65 grams divided by molar mass of chlorine is 35.5 grams. This comes as 2.02 moles. Okay. Now, step 3. Step 3 is divide the number of moles by the smallest number. Okay. Now, if we write these number of moles in terms of ratio, what can we write? So, C is to H is to Cl. Okay. So, first, what is the number of moles of carbon? This is 2.02. So, 2.02 is to moles of hydrogen is 4.07. So, 4.07 is to moles of chlorine is 2.02. So, 2.02. Now, we will divide the number of moles by the smallest number. What is the smallest number among these three? 2.02, right? So, we will divide all of these numbers by 2.02. So, we are dividing all of these numbers by 2.02. So, this is 1 is to, this becomes 2. Okay. So, when we don't have a total whole number, so here if we take up to 1 decimal place, or this is approximately 2, okay. But when we have some more ratios, like for example, let's say we have 2.5 or 2.4, in that case, what we will do? We will do is multiply with the next highest number. Okay. So, if whole number ratio is not possible, then we multiply by the next higher number. Okay. But here we can write 2, then 1. So, C is to H is to Cl is equal to 1 is to 2 is to 1. So, we have found out the ratio. Now, there is step 4. Step 4 is write the empirical formula by mentioning the numbers after writing the symbols of respective elements. Okay. Write the empirical formula by mentioning the numbers after writing the symbols of respective elements. So, C, what is the ratio of C? 1. Okay. H, 2 and Cl, 1. Okay. So, the empirical formula becomes CH2Cl. This is the empirical formula of this compound. Okay. Now, step 5 is writing the molecular formula. Okay. Now, writing molecular formula again has some steps. So, the first of this is determine empirical formula mass by adding the atomic masses of various atoms present in the empirical formula. Okay. So, we have to determine the empirical formula mass. So, we know how to determine molecular mass and all. So, we can determine the empirical formula mass. This was the empirical formula. So, what will be the empirical formula mass? By adding the atomic masses of various atoms present in the empirical formula. So, first, mass of carbon into number of carbon. So, mass of carbon is 12 into 1. Then, mass of hydrogen into number of hydrogen. So, 1 into 2 plus mass of chlorine into number of chlorine. So, 35.5 into 1. So, this will come as 49.5. Okay. This is the empirical formula mass. Now, step B is divide molar mass by empirical formula mass. Okay. What is the molar mass? The molar mass was given in the question. The molar mass is 98.96 grams. Okay. So, we divide 98.96 grams by this 49.5 grams. So, this comes as 1.99919. This can be written as 2. This is our N. Therefore, N is equal to 2. Now, step C is multiply empirical formula by N obtained above to get molecular formula. Okay. So, we have to multiply this empirical formula by N. N is equal to 2. So by multiplying all the atoms by 2, we get C2H4Cl2. So this is the molecular formula. So we got it, how to calculate empirical formula and molecular formula. Now we will complete this unit with one example. In the example, we have to find molecular formula and empirical formula of fructose. Okay. Percentage of carbon is equal to 40%. Hydrogen is 6.716%. Oxygen is 53.29%. And molar mass is given as 180 grams, or molecular mass is 180 mu. Okay. So let's find out what was the first step. The first step was we have to convert percentages to mass. Okay. So in step 1 we get mass of carbon is equal to 40 grams. Mass of hydrogen is equal to 6.716 gram, and mass of oxygen is 53.29 grams. Yeah. Now, what is the step 2? In step 2, we have to convert mass into number of moles. Okay. So, number of moles of carbon is equal to 40 divided by atomic mass of carbon, which is 12. So, this is equal to 3.33 moles. Then number of moles of hydrogen, 6.716 divided by 1. So this comes as 6.716 moles. Now number of moles of oxygen is equal to 53.29 divided by 16. So this comes as 3.33 moles. Okay. Now what we have to do? In step 3, we have to find out the ratios. So C is to H is to O. So 3.33, 6.72 into 3.33. We divide them. Okay. So this comes as 1 is to 2 is to 1. Okay. So in step 4, we find out the empirical formula as CH2O. Now we have to find out the molecular formula. So what we will do? We will first find out the empirical formula mass. This is equal to 12 into 1 plus 1 into 2 plus 16 into 1. So, this comes as 30. Now, we have to find out the N. N is equal to molar mass divided by empirical formula mass. Molar mass was 180, right? So, N is equal to 180 divided by 30. So, this is 6. So, now we find out the molecular formula by multiplying the empirical formula with 6. So, we get C6H12O6. So, we have completed the discussion of empirical formula and molecular formula. In the next lecture, we will study about stoichiometry and limiting reagent. Thank you.